I'm asking you to use the positive rational exponent. So I want you to rewrite these things with a fraction exponent. You have the cube root of x over the square root of x. A cube root is like what power?
1/3.
A square root is a... Now I do expect you to simplify. If you are dividing, what do you do with your exponents?
Subtract.
Subtract them. Okay, which one's bigger, 1/3 or 1/2? 1/2, so it'll end on the bottom. 1/2 minus 1/3 is 1/6. So your answer is 1 over x to the 1/6 power. Number 2. The fourth root of y to the -3. Okay, if you have a fourth root, what power is that? If you have a power to a power, what do you do with those exponents? And then, what would I expect you to do here? Put it on the bottom. Write it with the positive exponent. So 1 over y to the 3/4 would be our final.
So no matter what, we need to like make it positive.
Yes, I do want a positive exponent for the final answer. Okay, number 3. We have the square root of x squared times the cube root of x. So starting on the outside, there is a square root, which is what kind of power? Inside we have an x squared times a cube root of x is x to the 1/3. If these are multiplying, you add your exponents, so 2 plus 1/3. Be x to the 7/3. Power to a power, you multiply those exponents, so 7/3 times 1/2 is x to the 7/6. Okay, we didn't ask about it, but I'm going to go ahead and do it. On number 4, you have the cube root of z to the 4th times the square root of z. The cube root of z to the 4th would be what power? Times a square root is what power?
1/2.
If you're multiplying those, what do you do with your exponents? You add them, and you get...
1/6.
So make sure you can go back and forth between radicals and rational exponents. There'll be a section like that on the test.
Is there a way to like check those?
You could plug in a number, like say x is 3, and use your calculator, plug a 3 into this, plug a 3 into that, and see if you get the same answer out. I would try to avoid putting in like 2s if you could, but 3s would be good. Any other questions there? Then we had a question about 5 and 6, the domain. These are incredibly easy problems if you remember the domain, and if you don't, then there's no way you're going to get it. So these should be easy points if we can remember something. If it is an even root, what kinds of things can go underneath? Positive.
Only positive.
And only positive. So on number 5, we had the square root of 9x plus 18. This would be the same if it were a 4th root, a 6th root, an 8th root. If it is an even root, to find your domain, you take the thing underneath greater than or equal to 0. So subtract over your 18, divide by 9. X is greater than or equal to -2. So that'd be bracket -2 to infinity. How could you check yourself on that? Graph it. Put it in your graphing calculator and look, starting from left to right. Where does this graph go? Yeah,
I did that, but I just set it equal to 0, so then it's still not -2.
but then you didn't have the interval at the end. Okay. If it is an odd root, like number 6 was a 5th root, if it's a cube root, a 5th root, 7th root, any of those, what kinds of numbers can you do an odd root of? Negatives and positives. So on those, you don't even have to work anything out. It's just negative infinity to positive infinity. So if you know your domain rules, those are fast, but if you don't, you struggle a bit. Always, if you're unsure, graph it and look at a graph and see if you can get your domain from there. We didn't ask about 7 and 8. 7, you should have gotten -1 for your answer, and 8, -4 and -1 both work. Let's look at problem 9. Okay. Solving this radical problem. I've told you need to isolate one radical at a time. And out. I'm going to write it as radical x plus 3 minus 1, or you could have -1 plus radical x plus 3, either way. To get rid of a square root, we would square. When you do that, you do each side of the equation. So on the left, the square root and the square drop, and we just get x. On the right, if you have an addition or subtraction, that means you have multiple terms. So we have to FOIL. If you need to, write it again to help yourself. Radical x plus 3 times radical x plus 3 is just an x plus 3. Okay, because what that means, you have the square root of x plus 3 twice, because there were 2 of them, and square root and square drop. Outside would be -1 radical x plus 3. Inside, -1 radical x plus 3. Last, -1 times -1 is +1. So adding like terms, x plus 3 plus 1 is x plus 4. -1, -1 make -2 radical x plus 3. I want to isolate this radical. So if I subtract my x, those actually drop. Subtract your 4. You have 2 options right now. You can jump into squaring again, or what else could we do here? Divide by -2. Do you want to go ahead and do that? Give us an easier problem?
Yeah.
Since both of these are even, I'm going to go ahead. Otherwise, I would just square first. So I get 2 equals radical x plus 3. So then we square. So 4 equals x plus 3. Subtract your 3, and x is 1. What do you need to do at the end of these problems? Check it, because you will get answers that don't work. So if I plug in a 1, I get 1 minus the square root of 4, so 1 minus 2 is -1. It does work.
And if you were to square it before you divide it, would you have to take the square to the -2?
Yes. So -4 squared would have been 16. -2 squared is 4 times x plus 3. So subtract your 12, divide by 4, and you get the same answer. Wrong centimeter, right? We got lucky. Okay. Problem 10. Okay, this is a problem where, again, you have multiple radicals. However, it's a lot uglier than problem number 9 because these are cube roots. So to get rid of them, you have to cube it, which means you have to write 3 times and multiply it out 3 times, which is a mess.
But I thought you could make it easier.
Yes. So that option is going to be a lot of work and very ugly. So I'm looking to see if there's something easier I can do. What I noticed is this exponent is 1/3, and this one is 2/3. So this is like a quadratic. If it's like a quadratic, we always start out by setting it equal to 0. So I need to subtract over my 3. So this becomes a minus 3 equals 0. And then we want to go into a box method. This is like a 1 here, so we can do the shortcut box method. You always take this first term and divide it up for the 2 parentheses. So it's to the 2/3 power. Half of 2/3 is 1/3. Then I need 2 numbers that multiply to -3 and add to +2. Is everybody with me there? So then we are going to set each of these equal to 0. A 1/3 power is like a cube root. So if I subtract over my 3, how do you get rid of a cube root?
Cube.
-3/3 is -27. Add your 1, divide by 2, and you get -13. Over here, add my 1 to get rid of a cube root. We cube each side. 1 to the 3rd is still 1. And you get x equals 1. What should you be doing at the end of all these? Take time to plug them back in and check. For our class today, I'm not going to show you how to do that. I think you can all do that on your calculator, but these do both. Are we okay with page 1? Let's go to page 2. So problem 11. We have 6x to the -2 plus x to the -1 equals 2. There are 2 options for doing this problem. Some of you subtracted over the 2 and then did the box method. Others rewrote this. A -2 power puts that square on the bottom. Keep in mind, exponents only touch what's directly in front of it, so it's not touching the 6, just the x. X to the -1 would be 1 over x. And then you guys got rid of the fraction. Okay, no matter which route you take, you're going to be correct. Which way do you want me to work it? Fractionally? Okay, so what would I need to do here? Take everything times x. So we get 6 plus x minus 2x squared equals 0. We like our quadratics to be equal to 0. I usually put my squared term first, and I would like my squared to be positive, so I'm just going to make it a 2x squared minus x minus 6. So I just brought everything to the other side. Okay, so from here, we have to do the full box method. These multiply to -12. Then I need them to add to -1. Okay. So then if we factor 2x squared and -4x would be a 2x, 3x minus 2. If we set those equal to 0, 2x equals -3, so x is -3/2, and the other one, x equals 2. Again, you should check, but you can use your calculator and plug them in, and it does. Okay. Do I need to work the other way, or any questions about that? start on the outside. I have square roots, so what's the opposite of a square root? So this square root and square would drop. And over here, those drop. Now what do I need to do? Square again. You can divide the 2 over if you'd like. It will give you a fraction. Or if you want to avoid the fraction, we can just leave it here and square. So both ways we get the same answer. Which way do you prefer? Okay. So when I square, I have to square the 2, so it becomes a 4. The radical would drop. Over here, because it's 2 terms, you do have to FOIL. So you get 9x squared plus 6x plus 6x plus 4. So 28x plus 8 plus 9x squared plus 12x plus 4. We need to set it equal to 0, so subtract over the 28. Gives us a negative 16x. Subtract over your 8. There's a minus 4. Then what do we do? Box method. Can I do the shortcut?
No.
Nope. Have to draw it out. So those multiply to negative 36 and add to negative 16.
Negative 18.
Mm-hmm. So we get 9x and 2 minus 2. Set them equal to 0, and you get negative 2/9 and positive 2. Again, you need to be checking these, but those do both work when you plug them in. Questions there? Number 13. So if I am looking at this, I've asked you in the directions to write it without negative exponents. So I see right here is my negative exponent. What did we do? We factored it out first so that we could drop it to the bottom. When you pull it out, you have the 2/3, 2x minus 1, we pulled that out so it's gone, minus 2. When you factor out, you're subtracting exponents. So it's like 2/3 minus negative 1/3, which gives you just x to the first. Negative exponents drop to the bottom. No. We don't leave a fraction within a fraction, so we are going to take the top and bottom of this times 3. So the 2/3 times 3 would just be a 2. You do have to distribute the 3 to both terms. So that would be minus 6x. On the bottom we get a 3. It's the 1/3. 2x minus 1 squared. We can keep cleaning up the top. If we run our 2 through, add like terms, we get negative 2x minus 2 over 3x to the 1/3, 2x minus 1 squared. That is your answer for part A. Part B wants to know when this equals 0. If you set a fraction equal to 0, the first thing you do is multiply over the denominator, and 0 times anything is still 0. So it's really just when the top of the fraction is 0. And you get -1. And that's your answer to part B. No, it's just when the top. Questions? Problem 14. Deciding if it's 1-to-1. There are two ways of finding if it's 1-to-1. The algebraic way is probably not our preferred method, but that was when we did the f of a equals f of b. So algebraically, that would be 2 times a plus 1 squared minus 6 equals 2 times b plus 1 squared minus 6. 6's drop, then we can divide by 2. How do you get rid of a square root? Anytime you have a square root, you need as soon as I throw that plus and minus in there, what can I say? It's not 1-to-1. Okay, you might also, yes?
If you just see that it's a quadratic, because it's got a square, can you just say no?
It would depend on my directions. If I said decide if it's 1-to-1, you could say it's a quadratic, so no. If I say algebraically show me, you need to justify it. What's another way of deciding if it's 1-to-1? Graph it. You could put this in your graphing calculator, and you're going to get something like this. And what do you see?
It's twice.
This fails the horizontal line test, so not 1-to-1. So unless I specify how, you could use either of those methods. What does it mean if it's not 1-to-1?
It passes the horizontal line test.
Right, it doesn't. If it's 1-to-1, it passes horizontal line test, it means your y's never repeat. That's also what we looked at to decide if we have an inverse or not. It has to be 1-to-1 to have an inverse. Okay, so 14, good. And 15 was just your graph. Make sure on the test you show me the parent function with the minimum of 3 exact points, and also make sure your asymptote is clear. So if you move up or down, draw in the new asymptote with that. Okay, next page. So deciding or finding the inverse. You will have to do this on a couple problems on your test, and keep in mind this is a lot of points right here, so you want to make sure you know the process. The very first step was change your f of x to a y. Then we switch x and y, so it becomes x equals 1 over y plus 2. Now we are trying to solve for y. So you have to get rid of the fraction. So that's xy plus 2x equals 1. We're solving for y, so I'm going to subtract my 2x and then divide by x. How do I want you to write your final answer? F inverse inverse of x is 1 minus 2x over x. You might have also had, depending on how you did it, 1 over x with a minus 2 on the end, and that's okay as well. Then I asked for domain and range. We know that the domain of the function is the same as the range in the inverse. If I look at the original function, what can x not be? Can't be -2. So my domain would be -infinity to -2, union -2 to infinity. The range of the function is the same as the domain of the inverse. So you look at the inverse, what can x not be?
0.
So -infinity to 0, union 0 to infinity.
On the test, can we do that instead of
Sure. You can either list all 4 out or write it like this. Yes.
I actually don't really know what I did.
Okay. That's the second version I have. You have it right here. Okay, that's great. I did also state on this one to graph it. You could certainly use a calculator for that if you needed to. The original would have a vertical asymptote at 2, and it's going to look like this. When you did the inverse, its vertical asymptote is actually at 0. And like I said, if you need to, use your graphing calculator and look at that.
Just plug in that one.
Yeah, so you're going to plug in, your 1 minus 2x in parentheses over x if you need to. And this one actually looks like this. So if I did ask you to graph those, you could certainly use a calculator to help.
Do you not have to have the horizontal asymptote?
Yeah, I really shouldn't. That's 17. So change f of x to y. Switch x and y, so both of your x's become y's. Trying to solve for y, so multiply it by your denominator. We distribute, we get xy minus x equals y plus 2. What now?
Subtract xy.
Okay, if I subtract my xy over, that would give me a y minus xy. If you subtract your 2, get there. Then what do we do?
Take a y out.
So then you can divide. Final step, change it to an inverse. Now, you may have also, depending on which side you moved it to, you might also have x plus 2 over x minus 1. Those are equivalent, so either way is okay. Domain of the function is the same as the range of the inverse. What do you notice this time? It's the same. It's actually the original one is symmetric to the line y equals x, so it's its own inverse. The domain of that, we know x can't be 1, so it's -infinity to 1, union 1 to infinity. The range of the function is the domain of the inverse. We can't your inverse again, x can't be 1, so negative infinity to 1, union 1 to infinity.
I realize you do that, like, just list it once and then put it down.
That's
On mine, I got out negative x minus 2 over negative x plus 1.
That's-
equivalent, right?
yes, that is equivalent. Any questions?
So the graphs will look the same.
Yeah. I didn't ask for it on that one, but you could graph it from your calculator. How 20? We have to get a common base. I can't break 3 down, so it has to stay. A square root is like 3 to what power? That means x squared plus x equals 1/2. So quadratic, we always set those equal to 0. I don't usually try to do box method with fractions, so what could I do to this?
It's quadrant.
Yeah, what if we took everything times 2? You have a 2x squared plus 2x minus 1. Then what do we do? Okay, multiply to negative 2, add to positive 2. Is there any? Yes, ma'am.
Did you, in the parentheses, did you multiply by 2?
Mm-hmm.
Why did you do that?
Just to get rid of the fraction. What do we do if box method doesn't work? Quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2. So I get 4 plus 8, so it's the square root of 12. I can break 12 up into a 4 and a 3. Divide everything by 2. So quadratic formula is always still an option.
Could you plug that in?
You can, and you could get a decimal equivalent and plug it in if you wanted. Just account for some rounding error when you're checking. Is that one okay? 21. What do you do if you have a power to a power? So this is e to the 2x. So then you can set your exponents equal. Subtract over my 4x. Divide by negative 2. Okay, we have to get a common base. I cannot break down 2/3, so that's going to have to stay. 81 over 16.
2/3 and negative 4.
Okay. Do you guys agree that 81 is the same as 3 to the 4th, 16 is the same as 2 to the 4th? Since I want it to be a 2/3, that means it would have to be a negative exponent to put the 2 on top. And both of those to the 4th power would give you the 81 over 16. power to a power, we multiply. So negative 4x minus 4. So if we add our 4x, add your 1, we get negative 3/5. So if you ever need to change floors, you just make your exponent a negative.
Did you just make that one?
You want to write it as one big exponent, so make that big exponent negative. Okay. Questions there? Alright, 24. Okay, so this is something, we actually didn't do a problem exactly like this. When we are covering this section, I skipped the inequality piece just because I'm trying to make up for all the snow days and trying to get ahead. But it doesn't matter if it's an inequality. You are going to do it the exact same way. So I went ahead and left them on the study guide so we could talk about it here. If I have the cube root, that's the same as 5 to the 1/5 would be 5 to the negative 1. Power to a power, you multiply. So now we set our exponents equal. Only thing difference is instead of an equal sign I have an inequality in there. Otherwise it's identical. Yes. If you multiply or divide by a negative, it will still flip the inequality. So if I add my x over, divide by 2/3, we get x is less than negative 3. Technically, since it's an inequality, I could write interval notation. Less than negative 3 because everything's smaller, so it would be negative infinity to negative 3. Yes, ma'am.
When you change the 5 to the 5 1/3 and then the other one 5 negative 1,
Mm-hmm.
so they're not the same, so you have to distribute it and then it's the same? Or?
Well, they are the same base, but I had to simplify first. So power to a power, you multiply those exponents, so that we just had a plain 5 to a power on each side. 26. 23, just so you know, you should have gotten x to be less than 4/9. So it'd be negative infinity to 4/9. 25, you get x less than or equal to 2/9, so negative infinity to 2/9. So you can check yourself there.
Do you have to write the intervals on those?
Technically you should, if it's an inequality. 26. An investor has $40,000, so that's what they have right now, so that would be P, present value, or principal, to be invested for 3 years, so my time is 3. Which of the following plans would be the better option? Okay, so in plan A, your interest rate is 0.05 or 0.5%, so that would be 0.005. Compounded quarterly, so that means 4 times per year. So then use the formula. I will give you the formula, but I won't tell you what anything stands for, so you have to be able to use it. So our A, we don't know. P is 40,000. 1 plus 0.005 over 4 to the 4 times 3 power. Mm-hmm.
Why is the rate? For the rate, how many even decimals places?
Right, because I said 0.5%. If it has that percent symbol, you always move it back 2 more places. So the rate becomes 0.005.
I had 0, 0, 0, 0.
Oh, you had too many. Plan B, the rate is 0.4. So 0.4, it has the percent, that means I move it back 2 places, so 0.004. Compounded continuously. If I say continuous, that means we are using the PE to the RT formula. And you get $40,482.89. So you're investing. If you're going to make an investment, you want to get the most money out of it you can. So which one would you pick? Okay, you get more money there. Now, if you were taking out a loan, and this was the amount you're going to have to pay back to the bank, which one would you pick?
B.
B. So you have to think about the context to know, do I want the higher amount or not?
Can you just say the answer in 27?
Sure. It's $10,837.14.
14 cents?
Mm-hmm. Here, like 13.
I have 70. I'm gonna just write it down.
You rounded right here. Don't round. Divide by that whole thing. Put it all on your calculator.
So keep the, don't round until I get the final
Yes.
answer.
You have to think about, is this the amount I have right now, or I'm going to have in the future? So on 27, it's in 72 months, you must have. So that's in the future. So that's my A. On 26, right now, we had the $40,000. So that's our P. That's right now.
I got 25 wrong, but I don't know what I did.
Okay.
I did the same.
Should be 12,000. How do you subtract and one less? Yes. So test tomorrow.